And this is our official start of big data for today, so welcome everybody. Today, what we're going to talk about is a little bit more with the select statement in SQL, and in particular, two new things that you can do with it. The first is something called a subquery, and the second is something called outer joins. And these two things end up being very closely related to each other. So that's why they kind of go hand in hand to talk about them at the same time. This will also be sort of almost the last thing about select statements that we'll need to talk about. And so next week, what we're going to talk about is, instead of like how to access stuff that's inside of the database, how are you going to design the database kind of from the ground up so that it's easy to access and easy to work with. Still not quite talking about fast yet. We'll save that till after spring break, but easy instead of fast. See, so there's let's say everything we talked about last week or everything we talked about last class on Monday was things that were related to your Pagilla, the first Pagilla homework assignment. And so if you're still working on that, then that's okay, that the deadline was extended until this Sunday. And all of the joins that happen in that homework assignment are all inner joins, the type that we covered on Monday. But this coming homework assignment, it's the Pagilla 2 homework assignment's posted in the week 4 repository, or the week 4 folder of the class repository. You'll have to decide between using subqueries, inner joins, and outer joins throughout each of the problems. And so the problems end up being a little bit harder, and so there are also fewer of them. I've decided to also extend the deadline of the Pagilla 2 homework assignment. So if all the SQL stuff is feeling like a lot new to you, then you have until I guess the Sunday at the very beginning of spring break to finish it. So you'll have all next week as well. But today we will cover all the material that you actually need to complete the assignment. Are there any questions about, like, just administrative wise, anything related to that before we talk about the material? Okay. Maybe one last quick announcement is that about a third of you have completed that survey that I posted an issue about. And so if you haven't done that yet, I'd appreciate it if you just spend a minute to complete that survey. And with that, I'll share my screen. And yeah, so we began talking about joins last time. We will finish up our discussion of joins talking about these left, right, and outer joins sort of at the end of class today, but we're going to start with subqueries because I think it's easier to explain the outer joins in terms of subqueries. So I'm going to switch over to my terminal here. And now I am in the Pagilla Homework 2 folder instead of the Pagilla Homework. The contents of this folder is essentially exactly the same as the original Pagilla Homework, only now there are different problems in this SQL homework. The numbers go up to 7, but there's actually 8 problems. This 6 and 6b are very closely related. We'll take a look at how they're related in a second, or maybe a half hour. But essentially, one is asking you to solve a problem using joins, and one using this subquery technology. See, I'm going to start by having us look at this number 2 here, and we'll actually work through this problem as we explain exactly what subqueries do. So, yeah. Down above, we'll look through the SQL code. Down below, I'll do all of the sort of terminal manipulation. And at this point, I have no Docker process running, so I'm going to start our database exec, oops, not exec, up, and -d, make it run in the background. And it just has a single container in it, just like the Pagilla one with a database called PG. And when we want to access it, docker compose exec PG psql like this, and now we have access to it, and it has all the same information inside of it. There's absolutely no difference between this database and the previous database. And okay, so what this question is asking is the film's rating can be either G, PG, PG-13, etc. And this rating is stored in the film table. So let's take a look at the film table. In this rating category right here. Here, this type is MPAA rating. This is a user-defined type. And we'll talk next week about how you can do that and when you might want to. But essentially, they're just stored as strings. So if we were to say do select film, we'll do get the title and the rating from the films table, then you can see that this rating column just has the ratings stored. Essentially, you can think of it as strings for each of our different film titles over here. And so this problem sort of has two separate steps to it. Anytime you see something that sort of can be interpreted as having multiple steps to it, then that's a key that you should be thinking about subqueries. And when you have all of these steps, rather than trying to solve the entire problem at once, first try to solve whatever it looks like is kind of the innermost problem first, and then build up from there. So in this case, it's asking us to first generate a query that returns the two most popular ratings. So here, the most popular would mean count how many films have each of these ratings, and then pick the two largest. So rather than trying to type this in directly into the psql down below, I'll type the sort of my candidate commands up here on top, and then we'll paste down below once we have something that looks good. And again, this is sort of my typical sort of workflow when I'm working inside of Postgres. I pretty much never am typing things directly into psql unless it's just something really, really tiny, like I already typed in here. Pretty much always typing things into files, saving those files, and running those files somehow, either through input redirection or copy and pasting the code from the file. So let's, we want the two most popular ratings. So the first thing to do is sort all of the ratings by popularity. So let's select the rating and count star. Here, when we're thinking about popularity, somehow we're thinking about how often things occur. And so if you're thinking about how often things are occurring, this count aggregate function is the function that should come to mind. Of all of the aggregate functions that exist in Postgres, I would say I use the count one like 80% of the time, and then the other functions some smaller amount of time. So this is by far the most, at least in my usage, what comes up. And that's from the film table. And anytime we're doing an aggregate function, we have to have a group by clause, and we group by whatever the things are that it's not being aggregated over. So here, group by rating, like this. And in order to be able to copy and paste this again from this terminal down into this terminal, I have to turn the numbers off so that the numbers don't get pasted. So it's colon set, no number, like that. And now down here, Q to quit out of the pager environment and copy this down here. And here's all of the ratings and how often they occur. In order to get the most popular ratings, there's a number of ways that I could do that in SQL. So rather than getting all the ratings, only getting, say, the single most popular or the two most popular. The sort of trick that I use most often when doing this, though, is using that limit clause and an ordering. And so if we order by count star like this, so down here you can see that there's sort of no ordering in this this output. Whenever you don't have the order by clause, then we would say that the ordering is non-deterministic, that Postgres gets to choose whatever ordering it happens to be most convenient for it. And in order to make it deterministic, you include this order by clause. So let's just do that real quick. And now you can see that things are ordered from low to high in terms of the count over here. And in order to get the most popular, let's arrange it. Instead of ascending, we'll do descending, and then we'll do, start with limit 1 like this. And this would give me the 1 most popular, like that. And if I change this to 2, gives me the 2 most popular, and sort of so on. So you can set however many, if you want the most popular of something or the most of something, use the count grouping by and using the limit to specify how many things you're actually selecting.
Would it make a difference if you had in count, you had put in rating instead of the star?
Great question. So the question is, what's the difference between count star and count rating like this? And the answer is really subtle. And actually in this case, it's going to be exactly the same. If we rerun this, you'll see we get the exact same numbers here. The difference between count and then the name of a column versus count star is when there's null values in the column. So if there's a null value in the rating column, then count rating will not count that row, but count star will count that row. Sometimes instead of count star, you'll also see people use count 1. And this syntax here is equivalent to this, except 1 is guaranteed never to be null. And so that makes it give us the same value right here. Yeah, for the Pagilla database, almost all of the columns and almost all of the tables have this not null specifier in their schema. So if we did \d film, then I guess it looks like the rating is not actually not null. So it's allowed to have a null value in the rating. And so let's do this. Select count star from film. So there's a total of 1,000 rows. Select count rating from film. Okay, so it's still returning 1,000 because they all have a rating. Let's see if there's a different. Yeah, I think there are no null values in this film table. So even though we could have a null value here, we happen to not have a null value in any of the spots. So that's why they behave the same. Good question. Any other questions so far? Okay. So this query up here gives us the 2 ratings that sort of we're looking for to find the, let's see, then select the film ID and title columns for all films whose rating is one of these 2 most popular. So we have these 2 most popular ratings, and we want to select which films, all the films that correspond to these ratings. So the sort of naive human intervention multi-step process for doing this would be to select film ID and title from film where rating in, and then manually put in the 2 ratings that we got from this first query up here like this. And that would give us everything that that the question is looking for. But there's a 2-step process, really annoying to do 2-step processes in 2 steps. And so what we can do is actually substitute this whole query in for these parentheses right here. In SQL, parentheses have a really subtle meaning that it's not always meaning like order of operations like it means in other programming languages. And instead, parentheses actually mean create a table with this as the contents. So here, when you see these parentheses with sort of items inside of it, this is actually a table right here in the same way that film is a table. The only difference is that we might call this an anonymous table since it doesn't have a name, whereas this is a named table since it does have a name. And since this is a table right here, whenever you see this in keyword, the thing to the right of it is supposed to be a table of some sort. We don't have to specify this table manually. We can specify it by using a select statement to create the table for us. The output of a select statement, if you're looking at it like this, is just a table. So we could substitute this select statement right here for this. We can't quite do an exact substitution because here this select statement has 2 columns, 2 columns, 2 rows, 2 columns, 2 rows. And the way to think about this column or this table right here is that it has just a single column with 2 rows. This is the first row, and this is the second row. This is the contents of the first column. This is the contents of, this is the contents of the first column, the only column in the first row. This is the contents of the first column, the only column of the second row. So we'll have to modify this select statement. So instead of also returning the count, it just returns the rating. And I'll do that like this. So this select statement now like that, if I were to run it down here, you can see it gives us this table, just has 1 column, 2 rows. So it has the same format, the same, we might say schema as this anonymous table right here. And now I can just do this substitution of copy this and plug it in down here. So I'll copy that out and paste my above table, say rating, and put this whole thing in parentheses like that. And I'll format it a little bit nicely as well. So it's a little bit more obvious maybe how things are lining up like that. And again, everything in parentheses here is exactly the same as everything in parentheses up here. So if I copy that down here, we get the same exact results as if we used this instead of this. Are there any questions about that? Okay. So in the homework, you will never have a situation where you have to do nested subqueries. So like here's a query with a query inside of it. It'd be perfectly valid to have another query inside of this, or to even have like multiple subqueries going on. So where rating is in this, or rating, and I'll just do a simple variation. We want either the 2 most popular or the 2 least popular. rating in, and now I'll order by ascending instead of descending. You can have as many of these subqueries as you want, and so you can generate like really complex queries this way, but your homework assignments are not going to require that, at least for this assignment. These subqueries, they also don't have to exist sort of just in your where clause. They can exist anywhere where a table is a valid thing to have. So you can have a subquery right here. And instead of selecting from film, you can select from some subset of the film table, which is extracted using the select statement as well. So here, in order for me to make this valid, I'll have to extract the film ID and title so that I still have access to film ID and title. And then that, whoops, from film. And this would be a, if I don't have any typos, another valid and equivalent version of the same thing. So here, this, if you have a subquery that comes right after a from statement or after a join statement, then Postgres doesn't want to make this a fully anonymous table. It wants you to label it somehow, and you can label it using this as keyword, just like we were labeling columns up here. So as subquery. And let's see, since I can't copy and paste everything at once, I will just edit it here as subquery. From, let's have a,
Is that parentheses right above the from film supposed to be there?
right above the from film. This is this one here. No, that is not supposed to be there. That one is, so thank you. This parenthesis is supposed to match that parenthesis, since this is our select statement that's extracting information. Rating does not exist. So here, rating is not, because we've extracted only these two sort of columns from the film table. Down here, you don't have access to any of the information that's sort of only inside of a subquery. And in order to have access to this rating variable, we'd have to extract it as well. And let's see, this up and down is a little bit annoying, so let's do side by side so I can copy everything. And there we go. This happens to give us the exact same information because here in this subquery, I didn't do any filtering. But we could get sort of really complicated by adding a where clause here to do some filtering, where, say, title, so using that like operator begins with an A. And now we're filtering here and then doing the matching down here.
So if you wanted to add another column with the name of the rating, where would you add that?
Let's see, so if in our output here we wanted to add another column, whatever information we're trying to add here must be present inside of this subquery table. So in order to have access to it, let's say right now we have access to these three things. So rating we could immediately access by doing rating like this. But if, say, we wanted to have access to the language ID, and it's hard to read, so here's the schema down here. Well, let's do release year. If we wanted to have access to the release year, we couldn't just say release year up here, because we're not actually selecting from the film table. We're selecting from this sort of temporary table that's called subquery. In order to have access to the release year, we'd have to be selecting the release year right here. And so now if we did that, it would be able to give us access to that release year as well. For all the homework assignments, some of them you can solve using subqueries inside of this section, but it's never required. None of them will require that you have a subquery inside of this section. The ones that require subqueries, they'll require it inside of this section. So if maybe like the purpose of this subquery is a little bit unclear at this point, that's okay. Just know that this is valid syntax. And in terms of the purpose of the subqueries, it's really this one right here that you need to focus on for being able to do the homeworks. Are there any questions so far about subqueries?
Yeah, I thought the percent stood for like any characters. So how would %A give us starting with A?
Thank you. Yeah, so %A is ending with A. So here we can see they're ending with A. I had a typo there. It should have been A % in order to start with A. There we go. And now here's titles that start with A. Good question so far. Any other questions? Okay. I want to show you real quick some minor syntax variations on this this form of the subquery, and some error messages that you're likely to run into when working. And so the first thing is, we mentioned before that this sort of anonymous table right here has only a single column in it. And so this subquery needed to have only a single column in it. If you accidentally included multiple columns, so rating and the count star like this, then let's just take a look at what that error message looks like. It says that your subquery has too many columns. So that one's pretty straightforward. In general, if you're using this in keyword, then your subquery over here has to have exactly one column and should probably have multiple rows. It's not required to have multiple rows, but if it doesn't have multiple rows, then in is probably not the right keyword that you want to have right here. Let's see. If you're doing a subquery that only has a single row as the result, then you can have alternative options here besides just in. You can have, what it will do is it will treat this entire result as a single value, since it is only a single value, one column, one row, and you can just compare on that as if it was a value. So if we set this to limit 1 like this, then this in syntax will still work. Like that still works. But we could also use, say, the equals operator, that rating equals whatever gets returned by this, I think PG-13. And it gives us the same results. If these were numeric results that we were getting, so if we were, instead of selecting rating, if we were selecting the release year, and let's just run this subquery real quick, see what sort of things we get. Group by release year. Again, whenever you get this error message saying something must appear in the group by, that means that your selects up here do not match your group bys. And run this, semicolon. We get different year amounts. We can say now where release year is greater than or equal to this number right here. Because it's just a single column and a single row, we can treat it as a value instead of as a table, and we can do things like greater than, less than, equals. We could add 1 to this, we could subtract, do any sort of math operations that we might want to do. And now that gives us a whole bunch of things that were released in, I guess in this case, everything's released in 2006. So the greater than is doing nothing. But if there were things other than 2006, it would give us results. If we were to change this so that we had limit 2 right here and are using these sort of syntax, any operator other than the in operator, then it'll give us an error message saying that that's, oh, I guess it didn't give us an error message because there's only one thing that's only one release year. So this is still giving us one result. Well, if it had given us a second result, so if we change it back to rating with this equals operator, then it will give us this error message of you can't use an equals operator or any of these sort of comparison operators for something that has multiple results. Are there any questions about that?
So why do we need the group by clause here? Because we're not selecting any aggregate functions that we're displaying.
Question is this line right here, why is this group by here? Is that right?
Yeah.
Okay. Yeah, so that's a good question. Let's illustrate it by looking at this query up here, which is just the subquery extracted out into a single query. And so here it's only extracting these 2 queries, and you're right, it's only getting the rating and there's no aggregate function column. If we had this aggregate function here, then it would give us these same sort of results, but adding this aggregate column. It's the fact that somewhere in the query there is an aggregate going on means that you have to have this group by. So whether the aggregate is here or whether the aggregate is here, it sort of doesn't matter. The sort of technical way to think about this this select statement, what it's really actually doing is it's actually using a subquery. It's doing something like select rating, comma, count star from this, but then doing just select rating from this whole query right here. And again, when you have a subquery that's inside of a from clause, you have to label it, and I'll just label it as T for table. And so if you don't have the aggregate clause in your actual list up here, internally it's equivalent to this sort of SQL statement, which is maybe, it's longer, but maybe step-by-step easier to understand because it actually has the aggregate function here. And then the outer select is just kind of removing this column. Yeah, that's a great question. Any questions about that or anything else so far? Okay. Then we're going to move on to talking about these outer joins and how they relate to these subqueries. So in order to do that, what we're going to take a look at, so I'm on the left Vim window, I'm going to quit out of this, and in the week 4 folder, so I'm going to do ls ... inside of Pagilla homework 2, shows me the contents of week 4. And we looked last time at this create tables ... create tables.sql file. And this was just an example SQL set of tables that was from that linked postgrestutorial.com website in order to illustrate how the join operations work. And we're using, so the explanation I'm doing in class uses these same tables, so you can compare my explanation to the explanation in that website. But I'm doing it in a maybe more slightly technical way than they do it on the website. The website is sort of more focusing on intuition, and here I'm focusing more on the formal definition in my presentation about what these join operations are doing. So the first thing that, let's see, very first thing we'll do, I'll go back to split screen this way, and let's clear our screen. And what I want to do is I want to take this file and load it into Postgres. And so the way that I'm going to do that is with the input redirection, so // create tables.sql. I think it's with an S. One of the things that you'll notice is that tab completion does not work at this point in Bash. The reason for that is that tab completion is actually the way it's implemented in Bash is that specific programs can override how tab completion works. So by default, tab completion always works for whatever files are on the file system. It will complete those. But for Docker Compose, because it's there are sort of multiple file systems that you're working with, whether it's inside the container or on your local machine, tab completion, they've chosen to disable tab completion for the Docker Compose command in order to sort of prevent you from being confused about where the file's located. So that's why when I'm pressing tab right now, nothing's happening. So create table.sql, and then with this exec, it's -t. And actually, so the way tab completion does work in Docker Compose is that it works on the Docker containers themselves. That if I press tab on the container name, it completes the container name for me. So even though there's no file named PG in my folder right here, I press tab and it puts PG here because it knows that's the appropriate, the only container that exists. Hit enter. Okay, so I did, I think, create tables like this. And now we will start pSQL again. And another, if you're holding down Control, as you hit the left and right buttons, it will jump one word at a time to help you get faster across on the command line. And hit enter, and now we have access to this basket A and basket B. Tables. Are there any questions at this point what my setup is that I'm working with? Okay. Then, so what we saw last time, we introduced first the cross join that you can do select star from basket A, comma, basket B, like this. And let's go side by side again. This cross join is when you have the from and you have multiple tables listed and they're separated by a comma. This is the cross join. And we would say that I've done a cross join between the basket A relation and the basket B relation. And what the cross join does, again, is that, so if we just look at a single one of these tables, there's basket A and basket B. it takes every row in the leftmost table, so every row in basket A, and matches it with every row in basket B. So we have the row 1 apple, and then all 4 of these rows right here correspond to these 4 rows from fruit B. And so you can see that every row is multiplied a number of times for both tables, for both the fruit A and the basket A and the basket B table. Things get repeated many, many times. And then the inner join, the idea was that we add a where clause to this cross join right here, saying where fruit A equals fruit B, fruit A equals fruit B. And this is the inner join of basket A and basket B on this condition right here. So the alternative syntax for this, the sort of simpler, more common syntax, inner join basket B on. So use the where condition when you're just doing a select filtering from a select, and you use the on condition specifically when you're using this join keyword. And then this thing over here is the condition that you're joining on. And if I hit enter, we get the exact same results like this. Yeah, so the way to understand what an inner join is doing is you just first start with the cross join and then sort of find where are the rows that match. Apple, apple, so we're keeping that one. All of these other ones, they don't match, so we're discarding them. The, let's see. The outer joins are a little bit more complicated. And what the outer joins are doing is they're a way for us to fetch the information that gets discarded by the inner joins. So here we can see that this apple and this orange fruit are captured by the inner join. So from fruit A, this table right here, apple and orange are both captured by the inner join, but banana and cucumber are discarded by the inner join. Because if we look up here, look at the banana set of rows, there is no bananas in this rightmost column, so all of the banana rows here just get discarded. So in order, let's say we wanted to use a subquery to find all of the rows in fruit A that do not match anything in basket B. The way that we can do that is, so we'll select star from fruit underscore A, where, I guess it's basket underscore A, where fruit underscore A is not in select fruit underscore B from basket underscore B, like that. And I'm going to move this over here so that we can, what did I do? So that we can see it all printed out nicely and reference it later. So this query sort of got everything in fruit A, banana, cucumber, that was not part of the inner join. Inner join only got apple and orange, but there's apple, orange, banana, cucumber not contained in the basket B table. And this query right here extracts that information for us. Are there any questions at this point? Okay, then what an outer join is, outer join combines this query right here with the inner join. So first I will show the outer join syntax, and then I will show the sort of formal, exactly what does this combining thing look like. So if we do select star from basket A, left outer join I'll talk about what this left here means specifically in a second. Left outer join, basket B on fruit A equals fruit B, like that. Let's turn off the numbers so I can copy and paste this down here. Then here we get, so the very first two rows here, apple, orange, these correspond to the inner join rows. And these two rows right here, they correspond to this select statement right here. Everything that was not contained in the inner join. Are there any questions about that? Okay. The formal way of combining, let's see, so that's the thing that gets everything not in the inner join. So let's do the inner join, select star from basket A, inner join, basket B on fruit A equals fruit B, like this. So that's the inner join, that's the outer join, or that's the different part in the outer join. The formal way of combining these two queries together to give us the same, or to combine them into a single table, is with a union. So union statement combines results of queries sort of row-wise, like stacking them on top of each other. And so I can take these two queries and write another one right here, put this union keyword right there, like so. And this is going to combine the results of this query and just stack them on top of the results of this query. Should get an error message here saying, let's see. First, put these in parentheses like this. Near fruit A. Oh, I got an I, straight I. That's what the problem was. This error message right here, each union query must have the same number of columns. The problem here is that in this first query, so let me rerun this again. In this upper query, we're getting two columns, only the columns that exist in the fruit A table. And in this bottom one down here, we're getting 4 columns. And so if you're using this union operator, you can't directly add two tables that have a different number of columns. And so we have to add some columns to the sort of pad the number of columns that this one has so that it matches this so they can stack on top of each other. And the way to do that is you can say null, comma, null. And what this will do is it will create 2 new columns and it'll just put null as their values. This right here, equivalent to actually listing out the column names over here of A, comma, fruit A, null, comma, null. We'll just run this query, pads these, didn't give them names. It doesn't consider the names at all when you're doing this union. And now run this whole thing. And it gives me this result like this. You can see that the order of things is different than if I were doing this outer join sort of just by itself. And that's just because again, ordering in SQL is always non-deterministic if you don't use that order by clause, and it's allowed to return things back in whatever order you want. And on your machine, if you were typing these queries in, you might get different orders back just depending on random sort of things, internal state of your database.
Where would you put the order by clause for this query?
Good question. So And I think you're specifically talking about this union version right here. Is that right?
Yeah.
Let's see. So the way that I would do this would be select star from this whole thing so that we have a single table that we can reference as T. And then down here, we can do order by whatever we want to order by, say fruit A, or let's do it by the A column, order by A, like this. And now that's going to give us the same results. Any other questions? Those are all good questions so far. Okay, so I'm going to, well, let's see. Yeah, I mentioned that we're going to talk about what's the difference between, or what's this left thing here doing next. This left is because the basket A table is on the left over here. That's the table that we're including the extra information from. If we change this to right, like that, then it's going to include the extra information from the basket B column instead of the basket A column. And make the copy paste work. Oh dear. Come on, copy paste. Oh. Well, this terminal on the right seems to have frozen, so that's why the copy pasting is not working.
I think you cut out for me for like 20 seconds there. I'm not sure if you cut out for anyone else.
You did for me too. Okay. Let's see. Yeah, it looked like my internet connection had hiccuped there. What I was saying is that the so previously we were looking at just this left outer join, and that was giving us the extra information from the left table. The basket A table happened to be on the left. Change this to a right outer join. That'll give us the extra information from the basket B table. And a right outer join like this would be equivalent to a left outer join, swapping these two tables, just swapping the order that they're in. And so because you get different results here for basket A and basket B, depending on which order they're in, the left and right outer joins are not commutative in the same way that the inner join was commutative. You have to pay attention to which one is in which spot. If we change this to a full outer join, which I believe is just outer join, then it'll get us the results from both. There we go, gets us the results from both. This, yeah, the part that's optional is this outer keyword that you can always just say left join or right join or outer join, and it does that. Okay, so yeah, what we're going to do next in class is I'm going to take a look at the tutorial webpage. They have a couple of pictures that have some intuition behind them for these outer joins, and then we'll take a look at one of the problems from the homework and how to solve it using these outer joins. The sort of key intuition though, before we do that, is that just remember that if you're using an outer join, then somehow you're doing a subquery with this sort of not in inside of it. And so if ever you're interested in like somehow finding things that are not in something else, then that's the only situation where you might need to be doing an outer join. If you're not looking for something that's not in something else, then it's almost certainly an inner join that you want to be doing. I'd say in real world use cases, 95% of the joins that I do are inner joins. Maybe 5% of them are left or right joins. And I've never had a situation where I wanted a full join or a cross-product join. So let's come back over here and, whoops, scroll. Oh, I have it already open over here. So this is the page on Postgres Joins. And they have these sort of Venn diagram looking pictures that are sort of trying to describe in visual form what these different joins are doing. Each one of these circles, they're not really sets. It's not really a Venn diagram, but these are the sort of columns of the table. The inner join will get you only those rows where the columns exactly match. The left outer join gets you everything from the left table, plus things from the right table that are sort of overlap with the left table. It's possible to get only things from the left table that do not encounter anything in the right table, and that's the just this top part right here, this kind of query, only this not in. But let's see, so these are sort of very common diagrams that people will use to explain joins. This sort of is a maybe more funny version of that with this football player's beard and hair. But those Venn diagrams are not really technically correct. And so again, if you're looking for more explanations about these joins and how they work, this will give you a more sort of a more written version of the technically correct stuff that we talked about in class today. So this one here will give you the intuition. If you want some more technical details, that's this blog post right here. Any questions before we go into working on a homework problem? Okay, then the problem that I want us to look at is problem number 5 in the homework. So let's go back this way. Number 5. And so in this problem, it's similar to one that we looked at on Monday, where we're connecting the actors table to the customers table. And so let's take another look at that diagram over here. We had the customer table way up here and the actor table way down here. And we're going to join these two tables on this first name and last name key. So before, we wanted to find what actors are also customers. And the way we did that was by doing select first name, last name from actor, inner join, customer on, let's do using first name, comma, last name like this, and copy this into Postgres. And we had that there was just one actor who is also a customer, or one customer who is also an actor. What this problem, though, is asking is sort of like the inverse of that. We need a list of all of the actors who are not customers. And so you can do this using either one of these left-right outer joins or the not in operator. Anytime you have this, this sort of pattern of find everything in one table who is not in another table, you can use it using either one of these techniques. And from, say, like a performance perspective, there's no difference between them. They get implemented the exact same way in the database. It's just some people think that the joining technique is sort of simpler, more intuitive, and some people think the not in operator is more intuitive. So I personally think this one is more intuitive, so we'll start with this, and then we'll go to the joining. So here, select from actor. We want actors who are not customers, so we'll select from actor. And let's comment that out, where first name, so we'll start doing last name, not in select last name from customer, like this. And let's run that query. And it gives us 157 different rows. Here, it's just the last name that we're not checking if it's in or not. We also need to check if the first name is not in, one of the in the customers, because there could be a customer who has the same last name as an actor. And whenever you're using this not in operator, sort of one of the weaknesses of it is that this select statement over here has to just have a single column in it. So what I will do is first name concatenated with last name, select first name concatenated with last name, like this. And now it gives me there's 199 different actors who do not share the first name concatenated with last name of some customer. Let's say in order to make this pass the actual tests, it needs to be ordered properly and labeled properly. So let's go ahead and open up the, it's up here. Open up our expected output. This is problem number 5 that we're looking on. So first name, last name, ordered by, last name, first name, ordered by last name, then ordered by first name. So let's change that order. And then order by last name, comma, first name, like this. And I think that's correct. So I'll go ahead and test it, -t / check _ answers .sh. And problem number 5 right here is passing with this sort of not in solution. Are there any questions about that? Okay, so then the alternative to using not in is, comment that out, using a one of these outer joins. So select last name, comma, first name from actor, left join, customer on, and we'll go ahead and use the using, last name, comma, first name, and we'll start with that as our query. Open up the interactive P-SQL, copy this down here, and you see there's 200 rows. Again, in order to navigate this pager environment over here, you can use all the same Vim commands. So Shift-G takes me to the end, where there's the list of all the rows. Lowercase g takes me to the top, where it shows me the names of the columns. And those are commands that work in Vim as well. and press Q to get out of that environment. So this was giving me 200 rows. There were only supposed to be 199 because one of those actors is also contained in the customer table. And this left join is by itself giving me both the results from all of these, but the most actors have sort of null values in the results from customer. And so we need to use a where clause to filter out the customer or the actor that is in both tables. So in order to get an actor who is not in a customer, I'll say where customer underscore ID is null. And so customer ID is the sort of ID of this customer table. It only exists in this customer table, does not exist in this actor table. And so for all of the actors who are not in the customer table, they're going to have customer ID of null. Maybe to see that, I'll add customer ID up here before doing this where clause. And let's run this query. And you can see that customer ID is null for the vast majority of these, except for Jennifer Davis, who was the one customer who was also an actor, has a non-null customer ID over here. And so if we filter by saying customer ID is null, that will remove Jennifer Davis from our list. And I'm going to hit Shift D, go to the bottom. Now we have those 199 actors. Come up here. Let's now do our order by last name, comma, first name, like this. Delete that customer ID column. And now this should give us the same exact results as we had before. And it does, we can see under 5 here, getting a pass again. So whether we use this left join or whether we use this not in operator up here, you're going to get the same results. And in general, anything that you can do with joins, you can always do with an in or a not in sort of subquery. Any questions about that? Okay. So problem 6 and problem 7 are both using this having you do these same sort of techniques that will require either an outer join or a subquery. And problem 6, you'll have to implement both of them. There's 2 versions of the problem, 6 and 6b. It's the same exact problem, but one you have to use a not in and one you have to use a left join. So you get practice with both of those techniques. Problem 7, you'll get to choose whether you want to use a left join or a not in. It's up to you, whatever one makes the most sense to you. One last thing for today. So I mentioned that every outer join can be rewritten. So comparing subqueries and joins compared to joins, every join can be rewritten as a cross join plus a subquery. And that's sort of actually the formal definition of what the join is it's a cross join plus a subquery. So in some sense, like all you have to know is a subquery. There's no more power given by understanding what a join is. And subqueries are actually strictly more powerful than joins because if a subquery contains an aggregate function in any way, so like a sum, a count, so the example that we did for problem 2 that contained a count star inside of it, so it's impossible to rewrite that subquery as a join. So that makes subqueries strictly more powerful than joins. Yeah, I think that's everything that we should cover today. I guess if you're interested in more comparisons of subqueries versus joins, there's a good link that goes into the technical details. You will see for people describing for other databases like MySQL, SQL Server, and Oracle, people will talk about the efficiency difference between subqueries and joins. That's not really applicable in Postgres, that Postgres is capable of identifying that those two things are equivalent and will, in the vast majority of cases, have what we call a query plan that's exactly the same for both of them, which results in the same runtime. We'll talk about the details of that sort of, again, after spring break when we're talking about not just correctness of your SQL, but making it fast. But yeah, so if you are looking online, you'll see people comparing the speeds of them, but it's not really applicable in Postgres. Yeah, on next week, we'll talk again a little bit more about how you're to start designing these databases, and that really interacts a lot with how these joins work, that you have to, when you're creating these tables, deciding sort of in advance what tables you plan on joining with other tables. And so we'll take a look at that. But that is it for today. So I'll stop our recording. I'll stick around if anybody has questions, but otherwise I will see you all either on Friday. We'll have the lab again this week, or next week.